So I bet you probably guessed what was coming next. If you said solving radical inequalities, you were correct. So if you recall earlier, again, it's asking for us to solve this graphically. So that's good news because we could pull out our TI again. Again, I'm going to use the root zero method. And whenever I use the root zero method, I'm going to subtract everything from one side of the inequality to make sure that we have the inequality compared to 0. So just like we did earlier, I'm going to subtract x from both sides. So I have 7 minus x to the 1/2 power plus 1 minus x is now greater than or equal to 0. So in order for us to analyze the graph of this, the first thing we need to figure out is the solution to the related equation. So if you remember earlier, we actually solved this equation with the TI. So I'm going to call up our attention again. So let's go back to our TI. And we found that the root, or the 0, was x equals 3. So I'm going to copy that over. You can also make a quick sketch of your graph if you'd like. But I just want to annotate it on our screen. So let's see if we can do that. I'll take it off. Let's see if it'll copy on here, but sometimes it doesn't. We'll try it over here. Oh, guess not. Try one more time. Be patient with me, please. Sometimes technology doesn't work the way it's supposed to, as you've guessed already. So let's see if I can copy this one more time. You probably don't see what I'm doing, but I'll explain. I'm going to go back, see if it will let me. Oh, I guess not. Well, sometimes technology doesn't work, so we go back and we improvise. If you remember, I'll even scroll back up to my beautiful sketch up here. We do have the sketch of the solution of the related equation. Okay, so let's draw that over again just so that we could analyze it. And this, I guess this would be what you'd be doing anyway, so might as well. And so we have the graph, the root function does something like so. And we cared about the fact that we got a 3 as the root because that is the boundary point. Now that helps us greatly. Now when we interpret our graph, remember that we'd be looking for, if it says greater than or equal to 0, we would be asking ourselves what values of x give us y values that are positive. In other words, if you're talking about positive y values, we're looking for where is the graph above the x-axis. And so if you're testing each region, you can kind of look and you say, well, I notice if I have any point in this region that comes before the 3, if I find the corresponding y value, I notice that they're always going to be positive. So we can automatically say, okay, we have our winning region. So we can go to the solution and say, hey, it's all the numbers that come before 3. So if we're going to write this in interval notation, we have negative infinity. And if it's greater than or equal to 0, we're going to keep it to 3 with a bracket. So we've just solved that inequality with greater than or equal to 0. And you probably guessed what's coming next. What happens if we reverse the direction of the inequality? So we just scroll up a little and look what we did. We did reverse the direction of the inequality. So again, what I like to do when I'm dealing with this, I will rewrite it so that I see. Sometimes the process of me rewriting it does help me. I'm looking for less than or equal to 0. So pretty much recopying this. So again, you still refer to your graph. I will sketch it a little bit one more time just for you. That way we don't get a little messier. So we have our graph. We do understand that the boundary point is 3. And you're probably already understanding with your experience of solving with your TI, you're guessing it's got to be the other side of 3. So it's just the opposite of the example 5. There is a slight catch. You are right. But remember, just if you want to summarize, or you're still kind of working on interpreting graphs, less than or equal to 0 is asking us what values of x give us y values that are negative. In other words, we're looking for y values that end up being below the x-axis. And so you're kind of saying, okay, well, I do know for the most part, it can't be the yellow region that we colored up here. It must be the other side of the 3. And for most part, that is true. But I need you to be extremely careful because you can't name all the values of x on the right side of the 3. What happens is that it's only the values of x for which that function exists. So at some point, there is a stopping value for this particular function. And that has to do with the fact that you have a radical function and it's got a domain that we have to account for. So we basically need to figure out what is the x value where this function stops. So we're almost there. We have the idea or the picture of our solution. We just don't know what that value is. And I know that doesn't look like a question mark anymore, so I will draw that for you. So I do have an endpoint of my graph, and so we like to call it an endpoint, and that x value is a question mark. We're not sure yet. But a little bit of experience we figured out from the previous section, our function, whenever we have a 1/2 power, our function is actually a square root. So we have actually 7 minus x plus 1 minus x, if you're really looking at this. But I'm really just looking at the fact that I do have a radical equation. So I do have a radical equation or expression where the index is even. And so if you're looking for the domain of something with a radical where the index is even, you would set the radicand greater than or equal to 0. And if you look at the radicand, it's 7 minus x greater than or equal to 0. It's a nice linear inequality. What I'd like to do is I like to isolate the x on the left side. So I'm going to subtract 7 on both sides. So I have negative x greater than or equal to negative 7. However, I need to divide both sides by negative 1. But if I do that, the inequality symbol reverses. So I have x is less than, and you say positive 7. And you probably might have already guessed it because your previous experience. But now what happens is the point that you're finding is that particular x value. So when you want to name it, and you're just saying, well, how do I describe that region now? Your solution to this particular inequality, it starts at 3, and it goes all the way until x equals 7. And so now you've solved your inequality when you have a little bit of a wrench in the situation, those endpoints of those even index radicals. So I hope this helps. Practice a little bit more, and I'll see you for the next example.